Welcome, Pat Stakem. We very much appreciate you joining us tonight. For our listeners, tell us a little bit about your long career in aerospace. How did you get involved?
I guess it started out in high school. We did model rocketry. We had a tremendous physics teacher, and we enjoyed the rocketry, and we were asking questions like, how high did our rocket go? Which led into trigonometry, which led into trackers, So we learned an awful lot by somebody who was extremely good teacher. I'm still in touch with some of the model rocket guys. One of them went on to become an astronaut. So it was pretty exciting times there. My first job out of college, and I went to Carnegie Mellon in electrical engineering. My first job was at Fairchild Industries. They were building a satellite called ATS-6, Application Technology Satellite. And that's why I mentioned when von Braun got very sick and his government insurance wasn't going to cover him, he quit. And he went out into private industry. That he could have gone anywhere he wanted to, but I think he wanted to stay close. So he was out at Fairchild, or we overlapped, shall we say, at Fairchild. But I followed the ATS-6 spacecraft for 3 companies. I left Fairchild, went to somewhere else. So most of my kind of hands-on was at the Goddard Center, NASA Goddard.
Got it.
And I live very close to them. They sent me to all the other NASA centers at various times. We had some exciting things going on down at the Cape and at Marshall and Johnson and APL, JPL. So that just kept me going. So I wound up spending 42 years doing that kind of stuff, basically engineering and operations. And I have taught at 3 different universities. One was Loyola University in Maryland. They're not heavy hitter in technology, but they're not too bad. And then I taught for Johns Hopkins for a while, and for a small college or university, they call themselves now, very close to my house. They built it very close to my house, called Capital Technology, Institute of Technology. Excellent. And one of the exciting things I did there, I have a close buddy who's Brazilian, and he told me about this program in Brazil that let students come to the United States and do interesting work and interesting studies, and it was all funded by the government. They got a free ride, room and board, meals, and the tuition. So we set up a program over at Capitol, and it's almost walking distance. If I wasn't so lazy, I could have walked it. But we've focused on CubeSats.
Okay.
And I had them design and test. The one thing about Capitol is very interesting. They actually have a control center, and it's tied into NASA Goddard, which is about 5 miles away from them. And they train controllers, and I know a few that I met at Capitol. Now they're working over at Goddard or up at Space Telescope. So they had some nice facilities. We got our own ground station going. And what I wanted to do after that was capture the material, which I have in a PowerPoint format. And I'll ask you if you know a good way to make a recording of that, showing the PowerPoint while I talk through.
Yeah, you can do that right on Zoom, as a matter of fact. That's what we do with all of our videos. Yeah.
Yes.
Excellent. Okay. I'd really like to do that because I spent a lot of time and effort in developing these
It's a good
Right.
archive, right? It's a combination of you telling the story plus
You should have him speak to
the
the kids and you
visuals.
can
Yes.
record
Yeah.
it for him
We-
and then share it.
We can talk about that. Let's back up 50 years though. Do you recall, what did you think of when you heard of Sputnik the first time?
I was intrigued. I guess I was probably, say, 57. I was probably in grade school. But you know, I had to get back and watch it on the TV that evening in black and white, and you know, and then the Apollo missions came along, so I was hooked. You know, it was
Oh, yes. So let me ask one more follow-up question about your first satellite, the ATS-6.
yes,
Was every, I think of things in terms of boards today, right? The CubeSat, you have your boards that fit in. Did you build everything from scratch back in the day because they just hadn't been built? Or was there such a thing as, you know, you would hire a company to build a module or some sort of modular concept? Or was it everything from scratch? Everything was, you know, from the component level was assembled right there in front of the satellite?
yeah. Well, I kind of got there during the transition period. Up to that point, pretty much everything was built from scratch and without too much learning about what was right, what was wrong on the last mission. But Goddard came up with a concept they called the modular multi-mission spacecraft. And a lot of the there was what they call a bus, and then there was an instrument on top of it. And you left the bus part alone. It was made by Fairchild, and you just ordered one when you needed it. And then you put your instrument on top of it. And that's exactly, Hubble Space Telescope did it that way, a whole series of missions. And then when they brought the shuttle online, it had a specific structure that would hold that multi-mission modular spacecraft in place. And it could go up and, you know, kick it out, or in the case of Solar Maximum mission, we had to fix it. So they grabbed it and brought it back, which is incredible.
Wow. Yes. Yes. So even today, you know, the popularity of the CubeSat, I think largely is the fact that it's all pro forma. You can be very right out of a catalog on everything but your payload. And then you can, that's actually the secret to our working with kids is we only focus on the payloads and we decide on a nice bus provider, you know, and that takes care of a lot of elements that you don't have to worry about. And you focus entirely on the mission. And at middle school level, they haven't had calculus, they haven't had statics and dynamics and so many different topics yet, but they can do a good job on a payload. And then it's just a matter of integrating the payload.
Yeah. I kind of expanded on that a little bit in what I called Cube Rover, which is you take a CubeSat and you put it on a platform, and the platform can be tracked or wheeled, or it can fly, or it can be a boat, or, you know, whatever you want to do. And it turns out I was ahead of my time, because that's exactly what Carnegie Mellon is doing right now.
Oh, with astrobotics.
Yeah.
I've been there. We have literally been.
You want to use astrobotics in order to do your own rover,
yeah,
right?
we were trying to catch a ride with the Peregrine lander. And I'll tell you how it works. The middle school kids work on CubeSats, but my few high school kids, they're just trying to shove a drivetrain into a CubeSat and have a rolling CubeSat as their lunar rover, right? You take all the knowledge from your CubeSat and put in the drivetrain, and now you've got basically what you said, a cube rover.
Yep. It's interesting. I was working with a guy, volunteering with a guy over at Goddard, who used to bring in something like 24 seniors and grad students like to work on a project during the summer. And they actually got paid, so even more incentive. But we worked on a project for 2 years, and it successfully built and deployed a tracked rover in Greenland. And this thing was pretty massive. It was about the size of a small car.
Okay.
Tracked, and it had to store the data. It used not ground penetrating radar. You change the frequency and you get ice penetrating radar. They had to store all the data and then bring it back because we just didn't have enough bandwidth to send it. It's an incredible amount. So that was a very successful project and introduced a lot of college students to real life engineering, and particularly in air, and it was exciting. And as a footnote to that, I talked to the guy that ran the project just the other day and told him about a new rover they're using on Mars, and they decided to try it out in Greenland first. It's wind powered. It just blows across the surface and takes readings. As brilliant idea. We
Right.
built something that weighed 1,000 pounds, but they have this whole thing. It just wanders off. You don't have too much control over where it goes. It just follows the
Right.
wind.
Yeah.
Right.
I wanted to ask, you'd mentioned early about CubeSats. So approximately what year were you first exposed to CubeSats? And then I want to discuss from your perspective, did it take a long time for them to take off? And if so, what were some of the technological challenges that maybe have been alleviated since then?
Yeah, I probably learned about them about 5 years ago, I would say. And it took a while to understand exactly what was going on. These are not toys, these are real satellites. And of course, somebody had to design the dispenser for them and things like that. And now there's dozens of companies that, make kits or have components or whatever. So again, it's like the Goddard experience. All that stuff is off the shelf. Now put your very own sensor or whatever you want to do with it on that. So they caught on quite rapidly. In fact, the first one to be launched by a grade school was down here near me.
I do know that one. It was
Yeah.
I think it was a Catholic school. I think it
Yeah.
was.
Over in Virginia, yeah. So that's when I started to get interested in CubeSats and the things you could do with them. And I did a series of books on CubeSats based on the material that I had developed for the course.
And so that course that you were teaching, because Kevin was telling me a little bit about the book, the course that you were teaching, that was at the last university that you were at. Is that correct? So you
That's correct,
kind of had like an affinity. You kind of liked the idea of the CubeSat, so you then learned about it so you could teach your students. Is that right? That's the best teacher, I guess, right?
Yeah, and they had there were a couple things in their favor. They had a department of astronautics or something like that with a guy who knew what he was doing, and he had built a CubeSat. He hoped one day to figure some way to sneak it into orbit, but he was very good and he knew how to build and test and such like that. So we also got a ground station from the guys over in Greece and installed that, and that worked out pretty well. But the students were universally above average. They had to be to get here,
Right.
The Brazilian government was paying them a lot of money. So the first thing I suggested to them, we had an actual control center, which is where they did the teaching for the controllers. And we hooked it up to our CubeSats so we could, take a look at the units under test. But they quickly found out that, testing was 24/7, and sometimes it was raining and you'd have to leave the dorm and come over and all. So they took the control center software that we were using, which was a commercial product, and modified it so that all the data coming in was thrown up on a web page. Nobody had thought about this yet. I mean, it's so obvious.
So
when you're starting with something new, right? Invariably,
Yeah.
somebody's going to come up with something that hasn't been done yet.
yes, I will tell you, our team, we like using Global Star radios because for that very reason, I can't staff a ground station at the times when our little satellite's going to pass overhead. So we'll use these 23 Global Star satellites and let that network feed us to a nice dashboard, and everybody has the data. And it's a wonderful learning tool for the classroom because all the data can be downloaded as a spreadsheet. That's what I like
Great.
about it.
Yeah.
I'm thinking about your Brazilian students, and I'm thinking about what a great experience that must have been for them. Were you able to determine whether or not whether that changed the trajectory of their lives when they went back? I mean, obviously they were already going to be engineers, but how did that help them?
Yeah, I stay in touch with them on Facebook and LinkedIn. And they've all got very high-tech jobs. Some of them went on to complete their PhD. They're all doing marvelous things out there. So yeah, it definitely changed their lives. They wouldn't have been able to do that in Brazil. They just didn't have the infrastructure at the
Right.
time. So yeah, it really did make a difference.
And I'm sure that's very rewarding for you as well to have been part of that.
Yeah.
So are you a Pennsylvania kid? Is that where your home state
Maryland.
is? Maryland.
Maryland.
Okay.
Western
Very
end of
good.
Maryland.
Outstanding. So you're retired now. Are you continuing to write or to teach even though you're somewhat retired?
I haven't been doing any teaching. As I say, what I really wanted to do was take the material that I have already and put it online. I have been writing quite a bit. I mostly space topics. I seem to know more about this. Right before the James Webb mission, and I had been familiar with Webb, I used to take student tours in there and show them the thing in the clean
The high
room.
bay?
Yeah, and what was my point there? There was some point. Anyway, I knew Webb, and I have a very iconic picture of me standing next to it.
Yes.
Works
You
out
know,
well.
I was in I was there at Goddard years ago when the panels, the gold panels, I'm sorry, I forget what they're made of. It's what element?
Beryllium, I think it
Yes,
is.
I believe
Yeah.
you're correct. Each of those big hexagonal panels, they're
Yeah.
massive, right? And
Yep.
but I remember looking through the observation glass down at that. Was that like one of the world's largest clean rooms or what?
I think it is the largest clean room.
Yes.
Yeah.
Yes. It is. It is very. I don't think people get what a big deal James Webb was. The technical difficulty, the bureaucratic nightmare, and it all came down to a European rocket working well.
Yeah.
But
Yeah. So what I did was I'm always working on about 10 or 12 different projects, but I stopped momentarily and wrote a book on Webb, James Webb, which was a little bit, I don't want to say it was premature, but I was taking a chance because I was going to publish it before we knew that it all worked. In fact, we still don't know that it all works completely the way.
right.
But the nice thing about working with, I use the Amazon platform, it's very easy to revise books. So I had done this book on James Webb, and if you've been following it all on Facebook and such, it has just grabbed the attention of so many people worldwide. And I'm spending all this time explaining concepts of people to ask questions, you know.
Wow.
Right.
I
So
feel
you're
like I
still
should do
teaching.
it.
See, you're still
Yeah.
teaching, just in a
Yeah.
different.
Well,
Yes, sir.
we know the rocket put it in a very, the rocket was so precise that it saved a lot of fuel and extended the life on it. We
Right.
know that its mirrors are gradually, I don't know how many steps, the process to focus, but so far so good, right?
Yeah.
So far so good.
Yeah, so I will revise my book on that, which is a relatively easy process in a while. But what blew me away, because I knew people were interested in space at a certain level and stuff like that. So the month after I published the book, I'm looking down, I sold two of these, I sold 5 of those. I sold 600 Webb books.
Wow.
I mean, the interest out there is just unbelievable. So I'm doing an Artemis book right now, so getting ready for that mission.
I'm going to have to put you in touch with another friend of ours who bemoans the fact that there just aren't enough apparently space books out there. She's been writing for some time. She's an educator, and she particularly is interested in Florida's, space coast. And she really, as an educator herself, says good material, to teach kids about this at a younger age, but that's still informative and not like a Dr.
Right.
Seuss book is
Yes,
missing.
she wants books for her grandkids. That's what she tells us. So
Okay,
I'm gonna have to put you in touch.
that's how I write them, is for my grandkid.
That's exactly what she said. She said she's just starting to write them. She worked with a few of our students who were interested, who, you know, they weren't necessarily building the CubeSats, but they like to, you know, artistically make stories for younger kids. And so they worked together with her to write something on the ISS and vertical landings, but she just says there's just not enough out there. So I'm going to make the introduction. Just for the sake of time, as we've kind of come to the end of our podcast, I normally ask about words of wisdom, but I'm sure you have so many stories from your time in the industry. So as we close tonight, I'd like you to maybe share with us either a favorite story or both, what you think might have been the biggest contribution during the earlier space, you know, race, as it were, and to where we are now.
Biggest contribution. It's hard to say. I think it might have been the lunar landing when we pulled that off.
you mean
That's something that
when
keeps
they
me-
landed and returned safely, right?
And return to we're
Yes.
going to go to the moon, and oh, by the way,
And come back.
Yes,
and
I
so
agree.
that's
That was
why I think all the interest is now in something like the Artemis mission, because we're going back to the moon, and we might be taking that over to Mars. And I got 2 books in work. One is on Mars itself, and the other is a STEM-like activity called the Mars Railroad.
Okay.
Make the case for the railroad, and they say, and here's how we would have to do this differently than we do it on Earth, and that type of thing. So that's
Right.
Fantastic.
kind
That's
of
great.
crazy ideas I get.
Well, I'm going to invite you when we finish we're going to shut down our podcast in a minute, but I'm going to invite you to talk to my Wolfpack CubeSat team.
He also should talk to
Okay.
Dr. Lears.
And I also, yes, we have some organizations here in Florida that I think you'd be ideal
your
to share.
PowerPoint would be ideal right there too. So you can just
And
get the word out.
lastly, let me just throw out the idea. There needs to be a companion book to your web book that is about the cosmology and the earliest, the origins of the universe. And since that's what Webb is going to be looking at, right?
Yeah.
Back in history. I think that would be a great companion book.
Okay. I just wanted to mention, go ahead and give your friend my name.
I will.
And say, go on Amazon and type his name in, and you'll see the list of books.
Well,
And I would be more than happy to give her a PDF copy for free.
oh, I'm sure. I'm going to connect you via email. But while in our last few minutes, why don't you share out so everyone can go to Amazon, type in Pat Stakem, that's Stakem, and see a list of your books there. Is that correct? Do you have a website
That's
or anything else that you want to maybe plug?
That's probably it.
Amazon is good enough. So
Okay.
easy.
Well, I very much enjoyed your CubeSat book. I really appreciate, Pat, you taking the time to share with us just a little bit today. We are going to ask you back in the future so we can continue talking about your exploits, both past and
Yeah.
present. And we just want to thank you for being with us here today, and thank you.
This is very exciting, I think, and I'm thrilled I might be able to get back and influence some students.
Wonderful.
see that
Thank you.
happen.